Namaste. Welcome to this channel, Chemistry Made Easy by Dr.ARM. We were discussing this molecular orbital theory, in which we have seen up to this time the methods and rules of formation of molecular orbitals. Last time we have seen the use of s orbitals for the formation of bonding and antibonding or non-bonding molecular orbitals. Similarly, we have seen also the p orbitals, which when used for linear combination of atomic orbitals, how they give the sigma and pi type of molecular orbitals. Now we will see the next point of this topic, that is formation of sigma star, pi star, delta and delta star molecular orbitals from d-orbitals. Formation of this pi and or all these sigma star, etc. So we will discuss one by one. So first of all, we must know that there are 5 orbitals in the set of d orbitals. So these are the dx2 minus y2, dz2, dx2 minus y2, dxy, dyz and dzx. So these are various d orbitals present in the set. Now another thing is that we should know that, or we should not forget that we are considering always the z axis as internuclear axis. Z axis is used here always as internuclear axis. So using this, we will find that the atomic orbitals of this first, that is dz2, are shown here in this way. So without showing this axis, we can also show these atomic orbitals for different atoms of the same type. So here these orbitals are oriented in the direction of z-axis. So there is this first type. So this is these are 2 dz2 orbitals. So after addition of this LCO, linear combination of atomic orbitals. So first of all, we must understand that these orbitals are having different signs of wave functions. So it is shaded and unshaded. So these shaded wave functions, say, represents minus sign of wave function, and these are representing plus signs of wave functions. So same is the case here also. So this will give us the sigma bonding molecular orbital and sigma star, that is antibonding molecular orbital. So first of all, we will see that how these are shown here. So these two clouds, these two lobes are united together to form this lobe, and these are also changing here. Means this is actually reduced in size. The signs of wave functions are different, so we can also show these signs here. So this is, say this is, these are the signs of wave functions. So here we will have is, say, plus plus. So this will have plus plus. So there is, say, plus plus sign of wave function, and there is, say, this minus minus sign of wave function. So here we can have these wave functions in this way. So this will give us the bonding molecular orbital. Now the antibonding molecular orbital is shown like this. So when the signs of wave function, say this has plus, this has minus, when the two atomic orbitals are of different nature. So this is like this shown here. So these are having one type of sign of wave function, and these are having this type of sign of wave function. So we have such shaded lobes will indicate, say, minus 1/2 minus sign of wave function, and unshaded region will indicate the plus sign of wave function, that is positive sign of wave function. So this will show how the molecular orbitals of sigma type are formed from dz2. So because the dz2 orbitals are oriented in the z direction, then we will see the atomic orbitals of pi nature. So the formation of pi and pi star molecular orbitals. So here we will take the dzx orbitals, or we can also have the dyz orbital or dyz orbitals. So any of these can be taken here. Now we will represent these orbitals like this. So these are represented in this way. Now we can show these orbitals in this way. Again, this shading will indicate minus charge, that is minus sign of wave function. Similarly, so this will show the signs of wave functions like this. So after linear combination of their orbitals, they will give pi and pi star molecular orbitals. So here you will find that the resulting molecular orbitals of pi nature are like this. So this has this negative sign of wave function, and one have positive sign of wave function. So this will give us this. Similarly, we can have the other types of orbitals like this. So here these are unshaded and these are shaded. So from this we can understand the signs of wave functions. So minus 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 minus. These are plus 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 signs of wave functions. So this will give us the pi type of bonding molecular orbitals. And now we will see here the antibonding molecular orbitals of pi nature. So these are antibonding molecular orbitals of pi nature, and there are two orbitals which are shown in the slightly elongated form in this way. So we can show these with shaded and unshaded form. Say these are having shading like this. These are having the opposite signs of wave function. So these are called antibonding pi-type molecular orbitals. Now we will see the next type, that is delta type of molecular orbitals, which are produced from the x2 minus y, d x2 minus y2, or we can use the dxy orbitals or dxy orbitals. Now we can show these orbitals in this way. Like this. So we can view these orbitals like this. You can show, or you can see this. So there is blue end, so this small circle, and the bottom backside end. So this is larger ring structure. So the axis is like this. It is pointing towards us in 90 degrees, and this is pointing in z y direction. So it is x and y orbitals used here. So we will have this plus another orbital in the same way, like this. So we can use the signs of wave functions in this way in order to distinguish between these orbitals. Say these are negative signs of wave functions, and remaining two orbitals have positive signs of wave functions. So after linear combination of these atomic orbitals, we will get this delta bonding molecular orbital and antibonding molecular orbital. So during this, you will find that these orbitals are shown in this way. So we have to consider that the front lobe that is pointing towards us is coming together. This front lobe and this front lobe will come together, and it will be present like this. Similarly, there is also back, but that we will show later on. And now there are the upper lobes like this. We can show the upper lobes in this way, like this, and lower lobe like this. So there is, in addition to this, the backside lobe, which is arising from this backside lobe. So we can show this with in this way. Now we will distinguish these lobes with shading like this. Similarly, their front lobe is also shown with shades like this, and these are different. These are negative spins, these are having positive spins, signs of wave functions. So this gives us delta bonding type of molecular orbital. Now we can see how is this antibonding molecular orbital obtained. So for this purpose, we will consider the two lobes are shown like this, and there are remaining two lobes lying, one is lying in front of this. So we will distinguish with using different colors. And another lobe is lying like this. Similarly, we will show here to these different lobes, and remaining 2 lobes will show with this front line, and there is back lobe like this. So if say these lobes, if we say this lobe has say positive sign of wave function, then we can show this with shading, that is having opposite sign of wave function. Similarly, this will have also opposite sign of wave function. Then this will have the positive signs of wave function, and here you will find that these lobes will have opposite signs of wave functions like this. So in this way, this gives us delta star, that is antibonding molecular orbital. So everywhere this is bonding molecular orbital without asterisk, and with asterisk it is any orbital is antibonding. So without asterisk it is bonding molecular orbital, with asterisk it is antibonding molecular orbital. The bonding molecular orbital is lower energy, antibonding molecular orbitals are higher energy. Then we will see how are these non-bonding molecular orbitals obtained. Non-bonding molecular orbitals. Non-bonding molecular orbitals. So we have seen earlier that the s orbital is spherical shaped, whereas the p orbitals, which are like py, or we can have the orbitals like px, like this. So this is px. So we can choose this and this, or this and this orbital. So if these 2 orbitals are coming together according in the direction of bonding axis, that is a linear combination. So LCO, there is no appreciable extent of overlap. Further, what happens? We say this minus and this minus overlap takes place to small extent. Similarly, this plus and this plus overlap also takes place. So we can show representatively here. So that is s orbital. This is s orbital, and there is this. Say we can have this p orbital. Say there is very small amount of. So we can show this with here negative signs, and they say this is negative sign of wave function, there is plus, and this is plus. So if the 2 orbitals are coming together, so say this creates the bonding effect, and that is cancelled by equal amount of antibonding effect which is taking place here. So in this way you will find that these orbitals are not actually working for bonding effect, so they are directly transferred to the MO system, and they are called antibonding molecular, non-bonding molecular orbitals. Similarly, in case of d orbitals, so these are also, some of them are also of antibonding nature. For example, dyj. So these are having the lobes like this. These are the lobes, and these are, say, having negative signs of wave functions. Similarly, if we try to react or undergo linear combination with this dz2 orbital, so then also these lobes are, means electron density is lying in the direction of z-axis, but in these lobes there is no electron density in the direction of z-axis, therefore there is no appreciable extent of overlap, and no linear combination will take place, and there is no resulting bonding or antibonding molecular orbitals. So they are directly transferred to the ecosystem and called non-bonding molecular orbitals. Again, we have dy(z) and dzx, dy(z) and dzx. So these are also lying in the same way. So we can draw these diagrams like this. So we can show these in this way, and these zx, these are lying in the same plane. They are lying in the same plane like this. Like this. So we can show these with shading. Like this. So in this case also these are present in the xy plane and they are perpendicular to this xy plane, therefore there is no appreciable extent of overlap, and they are also regarded as non-bonding molecular orbitals. Again, the third case is dx2 minus y2, dx2 minus y2, and another is dx1, dx1. So the dx2 minus y2 orbitals are having structure like this. These are dx2 minus y2, and if we are having dz2, then they are having the shapes like this, So we can have so there is also no such appreciable extent of overlap. So they are also not capable to undergo any kind of linear overlap, and therefore they will produce the non-bonding molecular orbitals. So with this we will stop our discussion here. We will see the next point in the next lecture. Till then, goodbye. See you next time. Please subscribe to this channel and press bell icon and like button. Thank you very much.